Hi, and welcome to Mr. Fisher's Science Podcasts. This podcast is on bioaccumulation. In order to understand bioaccumulation, we first need to understand a couple concepts, and that's the idea of biodegradable and non-biodegradable substances. So biodegradable substances are substances that can be broken down in the environment. So plant matter, for example, household compost, these are things that are biodegradable. Non-biodegradable substances are either broken down very slowly or they're not broken down at all. And these can be known as pollutants. And so for an example of a pollutant, something like DDT, which is a pesticide we're going to talk about, and I'll show you an example, is a good example because it breaks down very slowly. Mercury, remember, is a metal, and it's another substance that can be broken down very slowly. And some common household ones include things like glasses and certain types of plastics. They're also non-biodegradable substances. So these pollutants can become toxins when they affect living organisms. So while a glass bottle may not have any direct effect on an organism and environment, something like DDT or mercury definitely can affect organisms, and DDT is right here. This is what DDT used to look like. We no longer use it in Canada, and we'll talk about it in just a little bit. So let's look at an example of biomagnification, also called bioaccumulation or bioamplification. Now these three words can be used interchangeably, and so for our example I'm using mercury because this is a common one in Manitoba where we have a lot of lakes and rivers, and there's a very prominent fish population. So with mercury, we can imagine that starting at the producer level, producers like zooplankton and algae may accumulate or may take in small amounts of mercury that have been remnants of lumber or other industrial processes. Now, while the mercury in the plant is actually very, very small in terms of its amount, remember that we have a food chain. As organisms move up the food chain, so as these minnows begin to feed on the algae, remember that in a minnow's lifetime, it's not just feeding on one plant, it's feeding on many. Now remember that mercury doesn't break down. So over time, the mercury is going to accumulate in these lower order consumers. Now, because we're moving up the food chain, if we move to this fish right over here, again, same thing. It's not going to just eat one of the smaller first order consumers in its lifetime. It's going to eat many. And so what we're going to notice is the accumulation again of toxins of mercury more and more. Now if we move up to, say, geese or fishers, other organisms that may eat these fish, we notice that the red dot, which is significant of the amount of mercury or the amount of pollutant, gets bigger and bigger, meaning that it ends up in the organism. Most of these pollutants end up getting stored in the fat cells of organisms. Now, where this affects humans, while with mercury it directly affects us because as we eat fish, that could contain even the smallest amount of mercury. Imagine how many fish you'll eat in your lifetime. And so over time, that mercury is going to build up until it reaches a toxic level. So that concept there, the buildup of toxins from trophic level to trophic level, that's biomagnification, bioaccumulation, or also called bioamplification. All three can be used interchangeably, remember. So let's look at DDT. We talked about DDT a little bit in the beginning. DDT was a pesticide. It was sprayed on wheat. And DDT was meant to attack grasshoppers. Now, grasshoppers, for the most part, died from the DDT, but some survived. Remember that DDT is a pollutant. It stays within the organism. So there was small bits of DDT in the wheat. Now, as that grasshopper, or as those grasshoppers that survived, ate more of the wheat, they accumulated some more of that DDT. And again, just like the mercury example, as we move up the food chain, that accumulation of toxin gets more and more until we reach the top of the food chain. And in this case with DDT, the top of the food chain was large birds of prey, particularly the peregrine falcons. And peregrine falcons became very affected, and in fact they almost went extinct because of DDT in the environment. Now, what's crazy about DDT is it's still present today. We can still find it in the environment in very low quantities, even though we banned it way back in, I believe it was the 70s. So DDT as a toxin, we thought it was safe for the longest time, but found out that it has negative effects on organisms. And that's a very good example to show bioaccumulation and how it can drastically affect organisms. So that concludes the podcast on bioaccumulation, and I hope that was helpful.